Right, let's have a look at part 2 of linear equations with numeric denominators. And this time we're looking at an equation with a number of terms, 5 different terms, and we've got a number of different denominators, so that's also going to require a little bit more attention. But first of all, I want to draw your attention to this term and this term. All other terms have just got a single thing on top of in the numerator, so x over 5, x over 6, etc. But here we've got a binomial over 3. So the fact that that whole binomial is standing in the denominator, it's acting as if it's in a bracket. So my suggestion would be, before you start doing anything, you remind yourself that this actually means x minus 9 over 3. In other words, the bracket of x minus 9 over 3. And here I've got the whole of x minus 1 over 3. And then we need to look for the denominators. So we're looking for an LCD, because when we presented with an equation that's got denominators, just like when we presented with an equation that's got brackets, the brackets are uncomfortable to work with, the denominators are uncomfortable to work with. We want to eliminate the brackets like we did in the previous episodes, and now we want to eliminate the denominators. And the only way to do that is to look for your LCD. So I'm going to go right back to one of my previous videos where I showed you the shortcut for finding the LCM or the LCD. And the way you do that when you've got a whole lot of numbers is you look for the biggest number. Consider that number. So we need to ask ourselves now, can the other denominators divide exactly into that number? Well, 2 can divide into 6, 3 can divide into 6, but 5 cannot divide into 6 exactly. So then we look at the next multiple of 6, 12. Again, those two are fine, but 5 cannot divide into 12. 18, same problem, 5 cannot divide in. 24, same problem, but when we get to the multiple of 6, which is 30, 2 and 3 can both divide into 30, and 5 can divide into 30. So now we know that our LCD is 30. So again, I'm going to set it out where I show you the thought process in orange. If your mental maths is very good and you're very sharp and you calculate things very quickly, then you're going to not write in what I'm writing in orange. You're going to do that in your head. But for those who still need to put that in, I'm going to include it. So what you do is you write down the term that you've got, and remember every single one of them has to be multiplied by the LCD, which is 30. You write down your next term, and remember now to write it as in a bracket. And we're going to multiply it by 30 plus x over 6. We carry on right through the entire equation, writing each term down and multiplying it by the LCD. Some people would feel more comfortable putting the 30 in front of the bracket. There's nothing wrong with that, because the commutative law says that when you're multiplying, you can write whichever factor down first. So x 30 times this bracket means the same as this bracket times 30. There I wrote it behind the bracket, it doesn't matter. So now once I've shown that I'm going to multiply every single term by the LCD, then I need to use the rules of multiplication for fractions, where you may cancel something in the numerator with something in the denominator. So 5 goes into itself once, 5 goes into 30 6 times. So if you were one of the people who weren't going to write the 30 down every time, all you would be doing is you would be saying, okay, my LCD is 30. When I multiply this by 30, 5 goes into 30 6 times, and you would immediately be realizing that you're left with 6x. So a lot of people are going to shortcut this. Remember that even if this is written after the bracket, when we get to the next step, it's still going to have to be multiplied by both terms. But let's not jump the gun. 3 goes into 3 once, 3 goes into 30 10 times, 6 goes into 30 5 times, 2 goes into 30 15 times, and 3 goes into 30 10 times. And because we chose the correct LCD, you'll know that you chose the correct LCD when all of these cancel out to be 1. And remember, when there's a 1 in a denominator, you don't write it down anymore. So x times 6 is 6x. And then, as I was saying, here, be careful that you're still going to use the distributive property. You're going to multiply the 10 by the first term and by the second term. So 10 times x is 10x. And then be careful here, we've got a positive times a negative, so it's negative 10 times 9, which is 90. 5 times x is 5x equals x times 15 is 15x. 10 times x is 10x. And then again, positive times negative, 10 times 1 is 10. And this is the stage you should always be very excited to get to. You have no brackets, you have no denominators, you just have terms on both sides, and now we're going to gather the x terms onto the one side and the constants onto the other side. So I'm going to take a bit of a shortcut here, and instead of writing all 3 of these terms down here, I'm going to quickly calculate them. So 6x plus 10x is 16x plus 5x is 21x. And then that x was on the wrong side. When I bring it across, it's no longer going to be positive, it's going to be negative. This one was also positive, it comes across as being negative. This negative 10 is on the correct side, and be careful to make sure you still write it down as negative 10. And then this negative 90 is on the incorrect side, so it's coming across the equal sign and it's changing its sign. So I'm almost home and dry because I have x's on the left hand side, constants on the right hand side. We just need to tidy up. So 21x minus 15x is 6x. 6x minus 10x is negative 4x. And negative 10 plus 90 is 80. But I don't want to solve for negative 4x. I want to solve for x. So I divide by exactly what that is. Do exactly the same thing to the other side. If you've divided by that coefficient, you will just be left with x. And I've got positive divided by negative is negative, and 80 divided by 4 is 20. And there is my final answer.